So in this video today, we're going to be talking about this really famous theorem about modular congruence, which is called Fermat's little theorem. So surprisingly, you don't pronounce the T when you pronounce this mathematician's name. It's called Fermat, not Fermat. Okay, so moving on to the theorem, what exactly is Fermat's little theorem? Well, it says essentially it says I have a natural number a, or I have an integer. So I have an integer a, and I raise it to the power of p. Okay, so as long as my p is prime and my a is an integer, essentially what's going to happen is a to the power of p minus 1 is congruent to 1 modulo p. So this is also given that the greatest common divisor between a and p is equal to 1. So that's just Fermat's little theorem. And this right now looks really weird here. So let's just try some things out. Let's just try 2. So a is 2. 2 to the power of 4. So 2 to the power of 4 can be rewritten as 2 to the power of 5 minus 1, meaning a equals 2 and p equals 5. Now, is p a prime? Yes, it is. 5 is a prime number. What's the GCD of 2 and 5? Well, it's 1, so this meets the requirements, meaning that 2 to the power of 4 should be congruent to 1 mod p, or mod 5. Is this true? Yes, it is. Why? Because 2 to the power of 4 is just 16. 16 divided by 5 equals 3 remainder 1. 1 divided by 5 is equal to 0 remainder 1. They both have the same remainder, so obviously they're modular congruent. So that's a small example. What about a larger example? Like, let's say 3 to the power of 10. Okay, so 3 to the power of 10. Now we can rewrite this into 3 to the power of 11 minus 1. So therefore a equals 3 and then p equals 11. So firstly, a few checklist items. Is p a prime? 11 is a prime, definitely. Is the GCD of a and p, which is 3 and 11, 1? Definitely. So yeah, we're good to go. The Fermat's little theorem should work over here. So 3 to the power of 10, I expect, should be congruent to 1 mod 11. Now, is this true? Well, we don't really know. We can't really calculate 3 to the power of 10 by hand. Let's just type this into a calculator. Okay, let me just search up calculator. So, 3 to the power of 10 is 59049. So let's divide that by 11 and see if the remainder is 1. So 59 divided by 11 is 5. 59 minus 55 has a remainder of 4. 40 divided by 11 is 3. So that gives a remainder of 7. 74 divided by 11 is 6. 66, so that gives a remainder of 8. 89 divided by 11 is 8, remainder 1. So yes, indeed, the remainder of that division is 1. And 1 divided by 11 equals 0, remainder 1. So the remainders are the same, and obviously the two numbers are congruent mod 11. So that actually works. Okay, so great. There are two examples here in this video featured about Fermat's little theorem. We learned the pronunciation of the Fermat, and we also learned the theorem itself, which is that given a is an integer, and usually it's positive, and p is a prime, and the GCD of a and p equals 1, then essentially this theorem here works. So thanks for watching.